So 13 people have joined. I think who is missing? MTech Nitesh Soni. Put on the camera, those who have joined, so that I can take a visual attendance. Nitesh Soni might be missing. So I think yesterday night I have emailed your marks and solution. I'll discuss about the solution, but before that, anyone who has, or else I will go question by question. We will quickly finish class test number 2. So keep your own solution ready. Class test number 2. Keep your own solution pages ready. So 3 into 12. So who is missing? Nitesh. Yeah, Nitesh Soni, MTech. I think you are absent. प्रसाद उसका क्या हुआ? नितेश का?
Sir, I have messaged him. I'll just make him a call.
No, don't make him a call. This is enough. No, I just wanted to know if he has any problem or he has left MTech.
No, sir. He's there. He must be.
Fine. Take it. See, one of the concept of introducing vibration for MTech student is that if they want to leave MTech, they can leave MTech. This is a tough subject. Richa, if I am not wrong, you were absent in last class.
Sir, I joined late.
Oh, take it. So, okay, we will not wait for Nitesh Soni. Remaining students are there. You can take out your camera. We will first discuss class test number 2 and then begin our next chapter. लेकिन क्लास टेस्ट नंबर 2 किधर है? तो नहीं दिख रहा. एक मिनट. I have not shared it, it seems. Yes, I will enlarge and then share. Okay, so look at the bottom part. I think it's not fully visible, so I will enlarge further. Look at the bottom 3 lines. So let us discuss question number 1 first. It's not necessary that you should agree with my solution. If you have done in a different, and I'm also not saying that whatever I have done is the best method. So for every solution, you can question me or you can suggest me if you have done by another method. But look at the solution for question number 1, which is at the bottom. Only look at bottom 3 lines. And then you can also look at your marks. Many people have got 4 out of 5. Why I have given 4? Because damping coefficient is missing. So I also realized that in the question I have asked damping coefficient, and even I also missed to calculate damping coefficient, but later on I have calculated its value is, correct value of damping coefficient is 115731, roughly 115731 Newton second per meter. So many students, they forgot to calculate damping coefficient. So I have given them 4 out of 5. Correct value of damping coefficient is, as I have mentioned just now, let me mention it once again, 115731. But if you look at the zeta value, then K and M value, whatever I have done, that is not the correct method. Can you tell me why that is not? Many people have done by a better method. So let me discuss what is that better method. See, you should interact. Don't remain deaf and dumb. Some of the students have solved this problem by a better method, better than my method. At least they can share what is the better method or what is wrong with my method. Can anybody point out? Remember, remember Q is equal to 1 by 2 zeta. That is an assumption. It's not exact formula. Number 1. Number 2, omega n is equal to omega 1 by omega 2 by 2. Even that is also an approximate. This is to begin with. To begin, we take omega n as omega 1 plus omega 2 by 2. If there is no other way to know how much is omega n, but this is an approximation. This is not correct. So we find zeta using two approximation. One is 1 by 2 zeta. Now this is correct as long as zeta is small. But this omega n is equal to omega 1 plus omega 2 by 2. It might have considerable error. So in the beginning, when we don't know anything, we use the approximation, calculate zeta. But from that zeta, we calculate omega n. But we don't go for K and M calculation. With that omega n, we come back here. So now we calculate omega, we don't calculate omega n as omega 1 plus omega 2 by 2. We calculate omega n from this formula. And use that omega n again, recalculate zeta. So that gives me 0.1757. With that damping, you again calculate omega n. So do the iteration. So with 2 and 3 iteration, it will finally settle down close to 0.176. Roughly 0.176, and omega n will settle down to 28.38. Use that omega n to calculate K and M. Okay, so you will not get this answer, you will get slightly different answer, but I have given marks. So those who have not gone for iteration, I have given marks, and those who have gone for iteration, I have also given them marks. But another beautiful method, some students have done it, they have directly used this omega n here. In place of omega n, if you use this, then this becomes a formula for zeta only. You have to solve that quadratic equation. Instead of taking omega n is equal to omega 1 plus omega 2 by 2, you can directly use this formula, 27.5 divided by square root of 1 minus 2 zeta square, omega n is equal to, you can use it there. Then you get a quadratic equation in zeta, and without any iteration, you will directly get the correct value of damping. So this is our question number 1. Any doubt, any query? Then I will go to question number 2. Any student? No. So let me go to question number 2. In question number 2, I think I don't need to explain anything. Transmissibility is 1.772, but some people have got transmissibility less than 1. I don't know how that is wrong. Transmissibility will be 1.772. Definitely, because excitation frequency is greater than natural frequency. Okay, excitation frequency is greater than नहीं नहीं सॉरी, एक्साइटेशन फ्रीक्वेंसी इज लेस देन नेचुरल फ्रीक्वेंसी. Excitation frequency is less than natural frequency, so transmissibility will be greater than 1. तो this is question number 2. पूरा देखो कहाँ पे गलती हुआ. I think no one will have any doubt here. Only one thing. No. I have a question. I have a suggestion for question number 3. In question number 3, I don't know. If you read the question, you will see nowhere I have asked to find out vibration of the vehicle. Nowhere. Unnecessarily, all of you, almost all the students have spent lot of time. If you look at the question, nowhere I have asked what is the vibration level of the vehicle. ऐसा क्यों किया? Can anybody explain? It is a small question, simple and very quick, not more than 5 minutes. But most of you have unnecessarily calculated vibration level of the vehicle. Can anybody explain or answer why he has done it? I don't know. I mean, if you have a reason, you can talk it now. You can discuss it now.
Sir, here it is written find vehicle vibration amplitude at 75 km per hour.
अच्छा, क्वेश्चन में लिखा हुआ था.
Yes, sir.
Let me see. Then I might have missed it. Let me see. Okay, I'll go through the question. मुझे एक मिनट, क्वेश्चन मेरे पास है. Let me see. Have a अरे वो किधर चला गया? ओह यस. Can you see anything?
No, sir.
I'm trying to bring back. Oh, भाग गया है screen. I'm trying to bring it back. अरे नहीं आ रहा. क्यों नहीं आ रहा? अच्छा, कैंसिल करके लाना पड़ेगा. हाँ, अभी आएगा. Yeah, now you can see it. Okay, so yes, in the question I have asked. So anybody that I have given less marks?
Sir.
नितेश कहाँ से पहुंच गया? थोड़ी देर पहले he was absent.
Sir, I joined at 11:07.
Is it a movie hall? At any time you can come and join.
Sorry, sir.
नितेश क्या प्रॉब्लम है? 3 में कितना मार्क्स मिला?
Sir, 5.
Then what is the problem? If you have got full marks, then no problem. But anybody who has done the vibration, he might have made mistake at other answer, and because of that, I have not given marks. Anyone?
Kishore, 86.
कौन किस एक मिनट 86 हाँ कितना मिला
8 marks, 1 mark.
1 mark. So I'll check it again. 86 question number 3 I'll check it again. ठीक है
Okay, sir.
और
Sir.
कोई हाँ
Nandana, sir.
अरे अरे इतने लोगों को एक मिनट बी ऑनलाइन लेट मी चेक इट राइट नाउ और कितने लोग हैं जल्दी से बोलो नो आई कैन नॉट चेक क्योंकि उसका कारण है आई विल नॉट चेक इट बिकॉज इमीडिएटली माई स्क्रीन विल गेट वैनिस्ड आई हैव अ प्रॉब्लम सो आई विल चेक इट लेटर अभी मुझे देखो स्क्रीन चला गया So Nandana and 86 they have doubt. I mean, they think the marks, so I'll check that. Okay, question number 3. Let me go to question number 4, where most of the students either they have omitted or they have made a mistake. This is the correct answer. Question number 4. So I'll keep it before you. Either you have omitted question number 4 or you have made a mistake. So I don't think you have, I have already given this solution. I don't think you people have any doubt. But already 2 class tests have taken place. I wanted to have 3rd class test, but the problem is syllabus is simply not going ahead. Generally, I finish this much of syllabus in 4 weeks. And today we are in end of 7th week. I don't know why this time classes are going very, very slow. One of the reason is, of course, online teaching. You cannot be very, very fast and very, very thorough. Okay, so I will skip then. I'll close this class test number 2 discussion and go to the let me begin this lecture. But anything you have regarding class test number 1 and class test number 2, both are over. One thing I can tell you, questions are not difficult. And second thing, during the class test number 2, I noted you are taking lot of time. That is bad. There is no reason. This class test should have been finished in half an hour. You can see whatever I have written, you have to write only that much. Maybe in 2 pages. I have done it in 1 page. You may take 2 pages. It should be completed in half an hour. I don't know why you are taking 1 complete hour. You have to see why you are taking so much of time, because in exam, number of questions will be more in 1 hour. There will be more number of questions in 1 hour. So you ask yourself why you are taking so much of time. I have taken 1 page. When you write it thoroughly, you should take 2 pages, not more than 2 pages. So half an hour per page is good enough. Okay, so let me go to today's discussion. And so let me open up the slide. Okay, can you see the slide now?
Yes, sir.
Yes, sir.
And we are beginning a new chapter, multi-degree of freedom, and listen very carefully. This is just a this is just a model. This is not anything in real life. Later on, we will bring examples of real life. This is just a spring mass model of multi-degree of freedom system. Any real life application will look similar, but not same. There will be damping, here damping is missing. A real life application may not be constrained at both the end. Second, a real life application may not be horizontal. For example, multi-story building. We can, or a car. Everything will be vertical. However, once we understand the mathematical technique, then we can use that understanding for any real life application. So this is not a real life model. Later on, we will discuss real life model, multi-story building, then detailed modeling of a car or even a rotor having many disks. We will discuss real life examples little later after the exam, not now. This is a very important chapter. This chapter will take almost 10 lectures. What is the heading of this chapter? Multi-degree of freedom. So far, whatever we have discussed, single degree of freedom or 2 degree of freedom. Single degree of freedom or 2 degree of freedom modeling is a simple model. Many times, actual system may not be represented by such a simple model. So we have to go for 3 degree of freedom, or maybe 10 degree of freedom, or maybe 100 degree of freedom. Don't get surprised. Mechanical engineers today, when they solve real life applications using finite element method, degree of freedom goes up to 50,000, 1 lakh. Fine. So multi-degree of freedom doesn't mean only 3 degree of freedom or 2 degree of freedom. Today, whatever actual problem we solve with a finite element software, degree of freedom goes up to lakhs, sometimes millions also. So by multi-degree of freedom, I am showing here only 3 mass points. So this will be 3 degree of freedom, but it doesn't mean that multi-degree of freedom will always 3. So this is a symbolic model. We will learn how to handle the mathematics. Once we learn the mathematics, that mathematics can be applied for any degree of freedom. 4 degree of freedom, 10 degree of freedom, vertical, horizontal, constant at both the end or constant at this end, free at other end. We can apply for any multi-degree of freedom system. But to begin with, I have taken up this model. Okay? Now, all of you write down your equation of motion. That is missing here. Write down the differential equation of motion using free body diagram, and then you check whether in matrix form you are getting this or not. So I'll give you 5 minutes. In exam, you have to write down. You cannot skip. Write down differential equation of motion, that is force equilibrium equation for each mass. Mass 0.1, mass 0.2, mass 0.3. You write down your equation of equilibrium for each mass and then combine these equations in the matrix form, and then you check, are you getting same matrix form as mine? Because in exam, I will not give you the matrix form. You have to get the matrix form. So how will you get the matrix form? First, you have to write down individual equation of motion. लिखो, खुद लिखो, फिर उसको मैट्रिक्स फॉर्म में ले आओ. I am giving 5 minutes. Have you completed? Are you getting this matrix form? Let me hear from you. Again, see, again, let me remind you, you cannot take so much of time, then something is wrong. You cannot take so much of time. 3 equations, 3 minutes.
Yes, sir. Same.
3 equations, 3 minutes. And then you combine into matrix form another 2 minutes. 5 minutes.
Yes, sir, it is.
Okay, so let me go ahead. In any multi-degree of freedom problem, what is the first step? First step is write down equilibrium equations for each degree of freedom. Now remember, the general approach is Lagrange equation. But if we have models like that, then free body diagram is quicker method, easier and quicker method. Very quickly we can write down the equations using free body diagram. I'll not advise Lagrange equation for this kind of systems. Lagrange equations generally we use for more complicated system where translation motion is combined with rotational motion and other things. In this case, I will advise use your free body diagram and quickly you will get the equilibrium equations, combine them, you get the matrix form. This is step 1. So what is step 1? Write down equilibrium equations and get mass matrix which will be diagonal and stiffness matrix which is not diagonal. Itna likho, these additional sentences you should write in your class note. Step 1 is write down equilibrium equations for each degree of freedom and combine them in the matrix form. Obtaining mass matrix and stiffness matrix. लिखे हो? Now, do you think you can yourself add one more sentence even if I don't speak out on this picture? In the matrix form, there is an important sentence you should write down yourself. What is that? सब चुपचाप है. Richa? अच्छा.
Sir, I'm thinking.
No. In interviews, this is the problem. In any interview, you cannot take 20 seconds to think because what I'm asking is a simple question. If you look at the matrix form, an important sentence you should write down yourself, even if I don't speak it out. What is that important sentence? Anyone else?
The matrices are symmetric.
A better sentence? Can you make it a better sentence? You are on the correct path.
Diagonally symmetric stiffness method.
अरे नहीं डायगोनल सिमेट्रिक डायगोनल के अगेंस्ट में ही होता है बट व्हाई आई एम नॉट
statically coupled.
no why what kind of sentence? A better sentence. His answer is more or less correct. Mass matrix is diagonal, so there is no question of symmetricity, or as diagonal matrices are always symmetric. So mass matrix is diagonal. Stiffness matrix is not diagonal. However, it is symmetric. This is the correct sentence. Mass matrix is diagonal. Stiffness matrix is not diagonal but symmetric. Now this sentence is important, going to be important in another 5 minutes. So if I ask you to take inverse of one of these matrix, which matrix you will prefer? Diagonal. Fine. And that is why all the discussions have some meaning. If we have to find out inverse of a matrix, we will prefer mass matrix. Okay, but even if we prefer, we cannot. Why? Let us see. Now what do we do? We have the matrix form of equations. So we apply the same concept, xi in harmonic solution form, capital XY, which is the amplitude, and sine omega t, which is the time function. So we assume that the solution exists in the harmonic form, and if we put this assumed solution in this equation, we get a modified form of equation. This modified form of equation is algebraic equation, whereas original equation is a differential equation. So do you agree that this will be a modified form of equation? And then what do? We take this common. So k minus omega square m, and then x1, x2, x3 is equal to 0. So that is homogeneous form. The determinant should be 0. So we apply here. अब इसको समझने का, if you want to write down, you can write down. I will give you the PPT. लेकिन समझने का कोशिश करो. So the algebraic form takes this shape. Let me go up again. थोड़ा छोटा कर लेते. Yeah. So my original, और थोड़ा छोटा कर लेते. Yes. My original equation was in differential equation. Original equation was differential equation. When I put the assumed harmonic solution, I get algebraic equation. And that algebraic equation is written in a shorthand form, where I don't write the whole mass matrix, I write as shorthand form matrix having capital M. K matrix with capital K. And this x1, x2, x3, which is nothing but mode shape vector, is written by a single x. So this is a shorthand form of this matrix equation. इतना तो लिख सकता. Now the moment I write this shorthand form, then I rearrange them. See what I'm doing. And here comes the question, why I have gone for K inverse. I could have gone for M inverse, but I have started with the more difficult option. There is a reason why I started with K inverse instead of going for M inverse. So this equation, if I pre-multiply K inverse both sides, I get this equal to X. Fine. So this is our starting line. This is our starting line for applying a mathematical method for multi-degree of freedom. The name of the method is matrix iteration method. Matrix. So now we are going to study what is matrix iteration method. To explain matrix iteration method, so you first write down K matrix, M matrix, K inverse nikalo. So we will solve this problem. By a very interesting method called matrix iteration method. To understand what is matrix iteration method, सबसे पहले K matrix का inverse निकालो. You know how to find out inverse of a matrix? K matrix का inverse निकालो. I'll give you 2 minutes. You have to be expert in mathematics. Remember, not because you have taken a vibration, but because you want to be an engineer. इतना टाइम नहीं लगना चाहिए. Again, we will use this formula, but before we come back to this formula, we have to find out K inverse. तो K inverse निकालो. So this is my answer of K inverse. Okay, I will go ahead, but you have to practice how to find out inverse of 3 by 3 matrix. In exam, I will not give 4 by 4 matrix or 5 by 5 matrix, but in exam, you have to know how to find out inverse of a matrix. So this is the inverse of a matrix right now. Isko, even if you don't know, you have to practice. इसको लिखो. दिस इज K इनवर्स. फिर यहाँ पे ले आओ. So omega square into K inverse matrix into mass matrix into X vector is equal to X vector. ये इक्वेशन को न्यूमेरिकली लिखो. न्यूमेरिकली K inverse, you know numerical M inverse, multiply K inverse with M. करो. Take this answer from me, but in exam you have to find out K inverse. इसको यहाँ पे डालो. मास मैट्रिक्स यू नो, एम डायगोनल मैट्रिक्स, दोनों को मल्टीप्लाई करो. देन दिस इक्वेशन न्यूमेरिकल फॉर्म में कैसा आता वो दिखाओ मुझे. डू इट. आई विल गिव 5 minutes. दैट विल बी द बिगिनिंग लाइन फॉर मैट्रिक्स इटरेशन. दैट विल बी द स्टार्टिंग पॉइंट ऑफ मैट्रिक्स इटरेशन. You see, you will get the equation in this form. And finally in this form. But you do yourself. You are not doing enough yourself. You are only looking at PPT and then thinking that you have become engineer. You carry out all multiplication with your own hand. Sometimes even my PPT also contains mistake. I'll be glad if someone points out my mistakes. So do it yourself. How to multiply matrices, how to take inverse of a matrix, practice karo.
Same, sir.
It has to be same, but do it yourself. Then only you also come to know how much time you need to get an estimate. So this is step 2. Step 1 I have already explained. Write down equations of equilibrium, equations of motion, and get the matrix form. Step 2, with harmonic solution, get the starting line of the matrix. This is the starting line. Starting line is this. This is the starting line of matrix iteration. This is the starting line of matrix iteration. So all unknowns, including omega and all parameters, they are transferred to the right hand side. This equation, nothing wrong. Even I can start matrix iteration with this line also, but I transfer the parameters and unknown on the right hand side. Left hand side only the numerical matrix remains. All parameters and unknowns are transferred to the right hand side. So this is step 2, end of step 2. This is the starting point of matrix iteration. Any doubt, any question from anybody? So I think some of you already know what is matrix iteration method. अभी हम क्या करेंगे? इसमें can you tell me in this form who are unknown that we should try to find out?
Next to x3.
Sir,
हाँ बोलो बोलो
Vector, sir.
नहीं Nandana, who are unknown that we should try to find out?
so the vertical X matrix.
X is not a matrix, first of all. X is
Sure,
a
yeah.
vector. X is a vector. This is Mortsev vector. We should try to find out Mortsev vector. But there is another quantity which is more important for engineers. That is natural frequency.
Omega.
And omega square, we call it eigenvalue. But if we get omega square, we can find out natural frequency omega. So omega square or omega is another unknown. And for engineers, this unknown is more important than the second unknown. But there is nothing like one among two, because if we can find out one of them, we can definitely find out the other one. There's an interesting thing. Both the unknowns are found simultaneously, थोड़ा आगे पीछे. So matrix iteration first tries to find out unknown omega. And once omega is obtained by us, we can calculate x. So the concept of matrix iteration is that in this form, there are two unknowns, omega as well as x. The concept is you guess x or you assume anything for x. Let me tell you, and little later, maybe after half an hour or next lecture, I will say, no, it cannot be anything. But right now, matrix iteration method says that you take any guess for x. Don't worry. तो बताओ किसी का मन में क्या आ रहा? I am asking you to take a guess vector for x. किसी का मन में क्या आ रहा? अपना बताओ guess vector. I am giving you freedom. You can.
1, 1,
Huh?
1.
So most usual anybody will suggest is 1, 1, 1. ठीक है? Agree? So you take 1, 1, 1. If somebody wants to take 1, -1, 1, 1, 2, 1, no problem. you can take any guess vector. But in exam, you have to be little more careful. But right now I am giving you freedom. And let us start with 1, 1, 1. तो क्या करेंगे? Matrix iteration method says, with the guess vector, calculate the left hand side. Calculate करो. Calculate the left hand side with the guess vector. Calculate करो. करो calculate. क्या मिलता है? Let me see.
Sir, 9, 15, 9.
Nine, 15, 9.
Calculate only the left hand side. क्या मिलता है?
9, 15, 9.
हाँ, now you will get a vector. You will get a vector. Then what you do? Topmost quantity को common ले लो, बाहर ले आओ. So you now take, in this place, you take 9 common. फिर अंदर क्या मिलता? So if you take 9 common, your right hand side, you got 9, 15, 9. Take 9 common and write it here. फिर a vector क्या बनता? देखो. So now 9, 15, 9. Take 9 topmost value common. You write like this. You get 1, 1.67, 1.0. Fine. Now, having obtained this, you go back to this equation. थोड़ा छोटा कर लेते so that you can see both. Yes, if you see this equation and this results, what comes to your mind? What comes to your mind?
Sir, 12k by m omega square is 9 and
No. Why no? Why no? Because this should have been same as this. It is not. It is not. This should have been same as this. Should have been, but it is not. Had it been same as this, then 9 would have been 12k by m omega square. Understood? If this vector is same as the guess vector, then 9 should have been 12k by m omega square. But it is not. So 9 is not 12k by m omega square. Which means my guess vector is not matching with a solution for x. If my guess vector is matching with solution of x, then after the multiplication, this vector will match with my starting vector. It is not happening because 1, 1, 1 is not matching with my solution. So what we should do? We started with a guess vector and we found out that this is not a solution. Of course, there is no guarantee that anything I guess, my guess is be correct. And that has happened here. This is nothing unusual. So what we should do? We should give up.
No, sir, we take next iteration.
So now what we do? Instead of guess vector, we take our second solution. So you repeat it. So this is now replace the guess vector by your second solution. So this is called result of second iteration. फिर से मल्टीप्लाई करो, देखो क्या मिलता है. So now you don't take 1, 1, 1. In place of 1, 1, 1, you take 1, 1.67 and 1.0. देखो क्या मिलता है. Continue.
Sir, 11.
Sir, 16.02, 21.03, 11.01.
So what you get?
11,
11, 21, 11.
11, 21, 11. What is that? हाँ नहीं ठीक है तो take 11 common. Take 11 common. Again, this is not matching with my starting vector. After the iteration, the vector should match with the before iteration vector. It's not matching. So we repeat the procedure. एक step और आगे बढ़ो. देखो क्या होता है. So go ahead. It's not matching. You stop when it is matching. So you continue the iteration again and again. And finally, okay. कितना मिला 11.73 1.9 यहाँ तक आया. Anyone who has gone ahead? One more iteration.
Yes, sir, I'm going forward.
So if you go ahead, because I have to end the class, if you go ahead, you will get 1.995 1.0. So here we can stop. Correct answer is this one.
Yes, sir, it's come.
Fine. So, however, my matrix iteration will take many more iterations to arrive at this correct answer. So, in matrix iteration, gradually we get the correct answer. Gradually. We may not get the correct answer, but we get an answer which is very, very close to the correct answer. So this is the concept of matrix iteration. And now 11.98, I can say that is 12k by m omega square. Now I can say that this number can be replaced in place of 12k by m omega square. And then I get omega square, I get omega. Omega comes out to be square root of k by m. Almost. It will be almost square root of k by m. So that is natural frequency obtained from matrix iteration. So I stop here, but many questions still unanswered. Number one, is it the only natural frequency? Definitely not. Then which natural frequency we are getting here? Is it first? Is it second? Is it third? That is question one. Question two, if we get the natural frequency, then simultaneously we are also getting the mode shape. However, how many iteration does it take? And after how many iteration I should stop? This is a very important question. I would like to get the answer from you in the next class. Next class is tomorrow, but I want to shift it to Sunday. Maybe around 11 o'clock. Are you ready? Jaldi se bolo.
Yes, sir.
Yes, sir.
Yes, sir.
All the students are here. Tomorrow's class, that 10 to 11, I want to shift it to 11, and that might be more than 1 hour because that will be the last class before exam. Tuesday, I will not take. Is it okay?
Yes, sir.
Or if you want Tuesday class, I will take. I'm not saying that Tuesday I will not take. But for the time being, Saturday class, I'm shifting it to Sunday 11 or 11:30. That you will get my link. तो आज इतना ही, लेकिन इसको practice करो and two question I have asked. How to know, I mean, which frequency is this and how many iterations we need. So this is matrix iteration method. आज इतना ही. We will meet.
Sir.
हाँ, बोलो.
Also,
before
what are these
exam-
answer?
One at a time. Nitesh, finish you. हाँ, बोलो Nitesh.
Sir, to eigenvalue solution, can we get this answer also?
No. See, I don't see. Timing is over. I have another class. So I am saying definitely I will answer your question. But जो question मेरे तरफ से उसका भी answer ढूंढ के रखो. I'll discuss all your questions Sunday.
Yes, sir.
हाँ, श्राव्या बोलो.
Sir, can we have a doubt solving session before mid-semester exam?
चलो Tuesday रखेंगे. No problem.
Okay, sir. Thank you,
ठीक
sir.
है. Tuesday रखेंगे. No problem. But let me finish this on Sunday. Little bit on Sunday. And Sunday, you can always ask. Once I finish it, maybe another half an hour or Tuesday. ठीक है? Okay. चलो आज यहीं पे खत्म करते हैं.